experiment, we are going to trace the path of a ray of light passing through a rectangular glass slab for different angles of incidence, and we will measure the angle of incidence, the angle of refraction and the angle of emergence with the help of a protractor and interpret the results. So the material required for performing this experiment is, you will need a drawing board, a rectangular glass slab, some office pins, a sheet of white paper, preferably an A4 size sheet, a protractor, and a sharply pointed pencil. So let us see how the experiment is to be performed.
To perform this experiment, we have placed a rectangular glass slab on a A4 size sheet which is white, and I am just drawing the boundaries of this slab with the help of a pencil. So you have to do it like this. Now we need some more drawing pins. You just need to draw one line before this. So I am just removing this and I am drawing a line at an angle to this surface of the glass slab. So this is the incident ray coming in, and at this point, if we draw a perpendicular, the dotted line that I am drawing here marks the perpendicular at this point, and this is the angle of incidence, which is I here. Now we will trace the path of this light ray when it travels through the rectangular glass slab. So I have placed the slab back. Now I will fix two pins here. The first pin and the second pin on the line that we made previously. After fixing these two pins, now we will observe these pins from this edge of the glass slab in such a way that the pins, they appear to be one behind the other. Let us see how to observe the pins. You can see two pins. Now we are going to adjust in such a way that we get a view of just one pin. So this is the perfect view. Now after this, we are going to fix two more pins in such a way that the four pins will be aligned in one direction. So I have placed one yellow pin here, which appears to be in line with the previously fixed two green pins, and I am fixing one more yellow pin in such a way that if you look through this edge, all the four pins, so this shows that refraction has occurred through the glass slab. Now I'll be removing these pins. I have marked the points where the pins were fixed. So these are the 2 points, point 1 and point 2 for the yellow pins, and point 3 and point 4 for the green pins. I am also removing the slab now, and we will complete the diagram. Let us join these 2 points. Using a pencil like this, and now we'll be joining this point, that was the point of incidence, and this point, that was the point of emergence. We will again draw a normal at this point. So normal is perpendicular to the surface. We draw it with the help of dotted lines, and this completes our diagram. Now after this, just measure the angle of incidence with the help of a protractor, and the angle of emergence also with the help of a protractor. You will find that angle I is equal to angle R. So you will repeat this experiment using different angles. You can take the value of angle I as 30 degrees. You will find that the angle of emergence will also be 30 degrees. If you take the value of I as 45 degrees, you will find that the angle of emergence is also 45 degrees. And if you take the value of angle I as 60 degrees, you will find that the angle of emergence is also 60 degrees. There might be a slight variation due to experimental conditions. So this is how we observe how refraction occurs through a rectangular glass slab.
Now, as you saw in the experiment, when we place the rectangular glass slab on the sheet of paper and we trace the path of light through it, we got an image as you can see on your screen. So the angle between the incident ray and the normal, this is the angle of incidence. The angle formed between the refracted ray and the normal is the angle of refraction, and the angle formed between the emergent ray and the normal is the angle of emergence. So when we extend the incident ray forward using a dotted line, we observe that the incident ray is parallel to the emergent ray, and for that reason the angle of incidence is equal to the angle of emergence. Also, the angle of refraction will be smaller than the angle of incidence, because whenever light travels from a rarer medium to a denser medium, it bends towards the normal. So the angle of refraction is going to be less than the angle of incidence. Similarly, the angle of emergence will be greater than the angle of refraction, because whenever a ray of light travels from a denser medium to a rarer medium, it tends to bend away from the normal. The results can be interpreted as you see in the table. When the angle of incidence was 30 degrees, the angle of emergence will also be 30 degrees. You can measure the value of angle of refraction with the help of your protractor and then calculate the difference between angle I, angle R and angle E. Also, the difference between angle I and angle E is almost 0 degrees. There may be a slight variation due to experimental error. Maybe you can get a difference of like maybe 1 degree or 2 degree, but actually if your experiment has been performed absolutely correctly, they should be 0 degrees, because the angle of incidence and the angle of emergence are exactly the same. Similarly, when you'll perform the experiment, when the angle of incidence is taken as 45 degrees, you will find that the angle of emergence will also be 45 degrees, and when the angle of incidence has been taken as 60 degrees, you will find that the angle of emergence has also been observed to be as 60 degrees.